Hey everybody, this is Mr. Mazzaro, and today we're going to start talking about how organisms stay above the ocean floor in the pelagic. We already talked about zones of the pelagic, but now we're going to talk about how they stay above the ocean floor in those zones. A lot of people think that the way organisms in the pelagic zone stay above the ocean floor is they just swim all the time, but that would result in them becoming exhausted and sinking to the bottom and dying. As a result, all organisms need to be adapted to actually stay above the ocean floor without swimming all the time. So, we're going to talk about how they do this in the epipelagic and in the deep ocean, in the mesopelagic and deeper oceans still. Specifically in the epipelagic, we're going to talk about how they increase drag and buoyancy, and then we're going to talk about the differences between vertically migrating fish and how they stay above the ocean floor, and non-vertically migrating fish and how they stay above the ocean floor. So we're going to start in the surface, then we're going to go to the deep. There are two basic ways organisms stay afloat in all of the epipelagic. If you're on the surface and you're in that top 2% of the ocean, there's really two ways that you're going to be adapted to stay above the ocean floor. The first is to increase your water resistance. The second is to increase your buoyancy. The first is to sink slower. The second is actually to float better. And all organisms are going to do both, if not one of these adaptations, if you're in the epipelagic. First, we'll talk about water resistance. In terms of water resistance, there's two ways in order to make yourself sink slower. You can have a flattened body shape, like all of these organisms, basically turning your body into a piece of paper that's going to float more softly down to the bottom when you stop swimming. The second is to have projections, and those projections are going to add drag to your body and allow you to necessarily sink slower as well. And a lot of these organisms with projections are going to also have a flattened body shape. You can see some copepods have a flattened body shape, other ones have projections, some have both, that sort of thing. So these are both ways that organisms increase their water resistance. If you look at all of these organisms, none of them are very, very complex. They're relatively simple. This is only true, sinking slower only works if you're a very small organism and an invertebrate. If you're a vertebrate, just sinking slower to the bottom isn't going to cut it. Your body's going to be too dense. So you have to necessarily, aside from increase your water resistance, you have to also increase how well your body floats. The way sharks and mammals increase their buoyancy, the way sharks or cartilaginous fish and mammals like dolphins and whales and us increase their buoyancy in the water, is by producing and storing fats and oils. As you know from oil and vinegar salad dressing, oil floats on water. So if you have a lot of fat inside your body and you're a fish, that fat is going to help you float better. In terms of cartilaginous fish, sharks, skates, and rays, they have gigantic yellow livers. And these gigantic livers are packed with fish oil. And that oil helps them to float, helps actually lower the density of their body so they can necessarily stop swimming and not sink to the bottom. It's a myth that sharks need to swim all the time. What's true is that sharks need to swim forward with their mouths open in order to breathe, but they can sit on the bottom with their mouths open and let water rush over their gills if the current's strong enough. The way they avoid swimming all the time is actually by producing fats in their livers. If you're a marine mammal, your main fat supply is going to be your blubber, which, like I said, aside from in the past chapter, we learned about how that helps you stay warm. It also is a fat and helps them stay afloat. So, mammals and sharks, in other words, whales, dolphins, cartilaginous fish, those organisms are going to stay above the ocean floor by producing and storing large amounts of fats or oils inside their body. Fish generally don't do that. Organisms that aren't sharks, skates, rays, or marine mammals don't generally produce large amounts of fat or oil. So how do they stay above the ocean floor? Well, the first is rigid gas chambers. There are two organisms that classically have these rigid gas chambers. This is an organism known as the chambered nautilus. This is an organism known as a cuttlefish. Both of these organisms have segments of their body that are filled with gas. And in the chambered nautilus case, it's these little areas inside of its shell. So there is nothing but gas inside these areas of its shell. And as a result, its heavy shell and dense body floats better because of the gas contained in these structures. In terms of the cuttlefish, they have cuttle bones. You may be familiar with cuttle bones if you ever had a bird. Cuttle bones are the things that you put in the bird's cage that helps them, they chew on it and helps give them calcium. It's actually from this organism, this octopus cephalopod looking guy called a cuttlefish. And at the head of its mantle right here, this area labeled 3, that's actually a cuttle bone. That's actually this thing. That is a bone, but it actually has the consistency of styrofoam. It's very frothy and foamy, and it has a bunch of tiny little microscopic air bubbles. And as a result, just like the chambered nautilus, all those millions and trillions of air bubbles help this organism to float. Problem with these rigid gas chambers is that they're rigid. They can burst, especially if the organism goes up or down too fast in the water and the gases inside these chambers expand or contract too fast. So, organisms adapted a second evolutionary adaptation to stay above the ocean floor, and it's seen here, pneumatophores. Pneumatophores in Greek mean pneumato, air, for pocket, means organisms with air pockets. This is a Portuguese man-o-war. This is an organism known as a by-the-wind sailor, and they both have these air pockets that stick directly above the surface of the water. And these air pockets keep these organisms afloat. The problem is, unlike the nautilus and unlike the cuttlefish, these organisms are basically completely out of the water. So, yeah, they're not rigid anymore, these gas pockets, and they still help this organism to stay above the ocean floor, but both of these organisms are planktonic. They're floating. They're macroplankton, but they're plankton. They can't move around in the ocean. They can't move away from enemies or move towards food. They basically, just as the name of the by-the-wind sailor suggests, get blown around in the wind, and hopefully they come across food. So, yeah, pneumatophores are a adaptation or a little bit of an advantage over rigid gas chambers, but necessarily they're not the best. Ideally, you would have something that's flexible as well as has the ability to move up and down in the water, and that's what fish evolved. Fish, bony fish, they have an organ inside their body. It's kind of a finger or cigar-shaped organ right by their gills, and it's known as a swim bladder. Swim bladders are hooked up to the fish's gills, and because of that, they can fill with gas, or the fish can actually extract gas from the swim bladder and exhale it. And by blowing up or deflating its swim bladder, the fish can control how much it floats or sinks in the water. It's internal and it's soft, so it's protected, and this is how bony fish stay above the ocean. If you ever opened up a fish, that large hollow cavity, that's not its stomach, that's actually its swim bladder. That would be filled with air. So, 3 ways that bony fish stay above the ocean floor. Gas-containing structures would be rigid gas chambers, like the chambered nautilus and the cuttlefish, pneumatophores, like the by-the-wind sailor and the Portuguese man-of-war, and swim bladders, like virtually all bony fish. That's just organisms that aren't sharks and mammals in the epipelagic, because keep in mind, sharks and mammals in the epipelagic, they're going to actually increase their buoyancy not through air pockets like rigid gas chambers, pneumatophores, and swim bladders. They're going to increase their buoyancy by having large livers in the case of sharks that have oil inside of them, or blubber. And not to confuse the matter even further, but if you're a smaller invertebrate organism, you're probably not going to have any organ inside of your body that increases buoyancy. You're probably just going to have projections or a flattened body shape that's going to help you to sink slower. That's all epipelagic. Now we're going to transition and we're going to talk about the deep ocean. And unfortunately, this is one of the times where we really have to differentiate between the mesopelagic and bathyabusal and hadopelagic fish. Before I talk about how organisms stay above the ocean floor in the deep, I have to start talking about vertical migration, because this is going to differentiate how organisms stay above the ocean floor in the deep. The largest migratory event on Earth happens every single night, and it's not locusts, birds, bats. It's not any organisms that you're really familiar with. It's actually virtually about 90% of the organisms that live in the mesopelagic zone. At night, these organisms are going to leave the mesopelagic zone and they're going to swim up to the surface in order to get food. And then as daylight breaks, they're going to swim back down. The reason they come up only at night is because the darkness is going to hide them from any predatory fish that are up there. The reason they're coming up from the mesopelagic zone and not the other zones is because that's the only zone that's shallow enough to get physically up and down in the course of one night. All those other zones, the bathy, abysso, and hadopelagic, those zones are going to be too deep for organisms to vertically migrate. If you're a deep sea fish in the bathy, abysso, or hadopelagic, or you're one of the few fish in the mesopelagic that don't vertically migrate, the way you stay above the ocean floor is you're going to lose all of your heavy defensive structures. Everything that would make you actually sink. You're going to lose your dense muscles, your well-developed bones, your spines, your scales. You're going to basically turn into a pile of snot like this guy, the blobfish. The reason they look like that is because they're non-vertically migrating fish. They've lost everything that would cause them to sink because they necessarily want to stay above the ocean floor, and they don't need any of that stuff because they're basically just going to float around ambiently in the deep ocean for their entire lives. Non-vertically migrating fish, that means about 10% of the fish in the mesopelagic zone, as well as every fish in the bathy, abysso, and hadopelagic zone, look like balls of snot because they don't vertically migrate, so they lost everything that would help them to vertically migrate. And on the other side of the coin, make them dense and cause their bodies to sink. Fish that do vertically migrate have well-developed bones, have swim bladders, have well-developed muscles. And necessarily, if you're a vertically migrating fish, the way you counteract the density of these well-developed bones and well-developed muscles is you have a swim bladder. In other words, vertically migrating fish basically stay above the ocean floor the same way as epipelagic fish stay above the ocean floor. It's just non-vertically migrating fish lack swim bladders. Why don't they need a swim bladder? Because they lost all that heavy stuff that would keep them on the ocean floor. So that's that. We talked about how organisms increase drag in the epipelagic. That's they have projections or they have a flattened body shape. And these are only the generally small, unicellular or very few multicellular primitive organisms. Then we talked about how organisms increase their buoyancy. That can either be through fat if you're a shark or a marine mammal, or it could be through a gas-containing structure if you're a marine fish, if you're a marine organism that isn't a shark or marine mammal. Those three gas-containing structures, again, would be the rigid gas chambers, pneumatophores, and then finally swim bladders, which is the most common. And then in order to talk about how organisms in the deep stay above the ocean floor, we divided them into vertically migrating fish, which basically just have swim bladders. And the reason they have swim bladders is because they need to make it up and down, and they have all the defensive structures, and they have all the muscles that's going to help them to actually vertically migrate every day. And non-vertically migrating fish, organisms that live deeper than the mesopelagic, as well as organisms that are in the mesopelagic, very few of them, that don't vertically migrate. These organisms are going to be your classic kind of weird-looking, ball of snot-looking organisms, these amorphous kind of gelatinous creatures that you see that don't quite look like fish. They just kind of look like round blobs. The reason they look like round blobs is they don't have any well-developed muscles. They don't have any well-developed bones. They don't have any well-developed structure. All of that stuff would make them dense and sink. And since they only needed that stuff if they're going to come across other fish, which are probably not in the deep ocean, they lost all of it to help themselves to float. So that's it for staying above the ocean floor. The next lesson is going to be on how organisms find food and or avoid becoming prey, avoid getting eaten in the epipelagic as well as the deep. And thank you very much. Have a nice day.